In this lesson, we'll discuss JSP Expression Language. Expression language was introduced in the JSP 2.0 specification. It is a very simple scripting language that we can use in JSPs. As the name suggests, it only supports expressions, so we cannot use it to write complex code. But it does make certain things a lot nicer and cleaner, like accessing bin properties and some common objects like request parameters. The syntax of the expression language is very simple. Just a $sign, a pair of braces with an expression inside. By the way, in case you forgot what an expression is something that evaluates to a single value. The most common usage of expression language is to access bin properties. In other words, we can use expression language instead of the JSP getProperty tag. Let's use the BG color example we saw last time and see how we can use expression language to replace the getProperty tag. So this is our bgcolor.jsp. It takes a BG bin which sets the red component of the background color to 255 and the green and blue component to 0. And in the JSP, we create that bin, and then we use getProperty to retrieve the red, green, and the blue components, or the R, G, and B properties from the bin, and that gives us the background color of red here. So instead of using JSP getProperty, we can simply use expression language here. It will be something like bg.r. The syntax is very simple, just a bin name dot the property name inside a expression. So just like this. And similarly, we can replace this tag with bg.g, and we can replace this tag with bg.b, and that's it. Make sure the expression is inside braces and then the $sign there. And if we refresh, still works as before. And if we change, for example, R to 0 and G to 255, it changes the background to green, just as we would expect, because we still have the set properties here, and the get property return these three properties. So as we can see, the expression language here does the same thing as before, except that with expression language, the code looks a lot cleaner. Now let's see another example. This time we'll use more than one bin class, and we'll also have some arrays and list properties. So let's begin with the bin A class, which I already have it here. As we can see, this is another bin class, and it has 4 properties: ID, name, weekdays, and the numbers. Notice that weekdays and numbers are string array and a list of integers respectively. And we initialize the property values to be 0 for ID, CS320 for name. Weekdays will be 5 strings, Monday, Tuesday, Wednesday, Thursday, Friday. And for numbers, we add 10 numbers into the list. And the first number is 100, and the second number is 101, third number is 102, and so on. So this is our bin class and the 4 properties. And let's create a JSP page and see how we can access these properties using expression language. I'll create my JSP file, and I'm going to call it EL test. And just like BG color, I'm going to create a bin in this JSP, and this bin will be of the bin A type, and I'm going to give it ID BA. Okay, so for bin A, let's say that we want to access some of the bin properties. And let's say if we want to access the ID property. So how do we do that? We actually already know that. We have seen how we can access properties in this BG bin. So the same thing here. If we want to access the ID property, we simply say BA.ID. And if we try it, we can see that it indeed shows ID to be 0. And similarly, we can try the name property, and the name property is a string which is initialized to CS320, so that would be BA.name, shows CS320 here. So how about the array property weekdays and the list property numbers? So for array property, let's say that we want to get the value of the second element in the array. So it would be something like weekdays, the second element, and the value for that is weekdays second element. And notice that it's just like what we would expect, and the syntax is something very similar to Java syntax. You use string index, and you specify the index number which starts from 0, so the second element is 1. And if we refresh here, it shows weekdays is Tuesday. Second weekday is Tuesday. So how about this list property? Well, we can actually do something very similar to array. For example, let's say we want to get the second number in the numbers property. So the second number in the numbers property would be something like this. And if we go back and refresh, it shows 101, which is indeed the second number we added to the list. Notice that here we can actually access list elements just like when we access array elements. For list, in expression language, we can use the array index instead of like in Java, where we have to say get 0 or get 1. Here it has exactly the same syntax as the array, and the Java virtual machine automatically, and the application server automatically translate that into a list get to retrieve the list element. So one more thing, if we look at this syntax, it still looks quite similar to Java, but expression language actually supports one more syntax like this. In Java, array index must be integers, but in expression language, we can actually use strings for array index like this one, and this will in fact produce the same result. And the way it works here is that the application server will automatically convert this string into an integer, which then is used as the array index. The reason expression language is designed like this is because HTTP is all about text. When, for example, a request parameter comes in, it is just a piece of text. So if we have to manually convert text to integers all the time, it's pretty tedious work, and expression language is supposed to simplify lots of that work. So it will try to intelligently convert some string values into numbers, and when it sees an array index, it will try to convert that into an integer, and so that we don't have to, for example, take a request parameter, then call integer pass int to convert it to integer, and then use it as a array index. The application server would do that for us, and the same syntax would work for the array too. So this, for example, is perfectly valid syntax, and what's happening here is basically that the application server will automatically convert some text into numbers like this. Okay, so now let's add one more bin, and this time this bin class will have some properties which of some other bin class type. For example, we have this bin B class. Notice that bin B class has two properties, get bin 0 and then get bins. And the bin 0 is actually of the type bin A, which is this class. And bins is a list of bin A. And in the constructor, we initialize both properties. For bin 0, we simply create a bin A object. And for bins, we create 10 bin A objects. And for each object, we set its ID value. By default, a bin A object would have ID 0. And here, we would set the ID of this bin A objects to be 1, 2, 3, 4, and so on. So let's see how we can access these properties inside our JSP. So for example, let's say we have bin B. Oh, we have to create a bin B here first. So let's create another bin object, and this object is a bin B. And let's say that we want to know what's the ID of bin 0. Well, to get the ID of the bin 0 property of this bin B object, all we need to do is say bin B dot bin 0. Notice that this will give us the bin 0 property of bin B, which is this property. And notice that this property itself is another bin, which means that we can access its own property by simply doing another dot. So we can say bb.bin0.id, and this would give us the ID of the bin 0 property. And similarly, we can say something like, let's get the ID of the second element in the bins property. So it will be something like bins, and then dot ID, and it will be bb bins 1.id. And just like that. So the important thing about this example, there are a couple of important things about this example. The first important thing is how to use expression language to access values in a list or an array. And as we can see here, you simply specify an index value, and that index value can be either an integer or a string. And the second thing is that oftentimes a property itself is another bin, so we can access the properties of that property just like this one. We can say bb.bin0.id or bb.bin1.id. And in other words, we can chain the dot operator, chain multiple dot operators together to access a chain of properties. And this is something that we'll do quite often, so keep this in mind. The property of a bin can be a bin itself. Okay, besides accessing bin properties, expression language can also be used to, well, write expressions. And that means the literals, the operators, the variables, and the combinations of them. Here are the literals you can use in expression language. As you can see, they are mostly the same as in Java. You have Boolean values, integers, floating point numbers, and null. Note that in expression language, strings can be either double-quoted or single-quoted, just like in HTML. And there is no char type because single quotes are already used for strings. And here are the operators in expression language. Again, they are mostly the same as Java operators, except a few of them, which I highlighted using a different color. For division and modulus, instead of using this slash and this percentage sign operator, you can also use the word diff and mod. And similarly, for logical operators and, or, and not, you can say and, or not, instead of those Java operators. They are the same except the syntax. They use a different word or symbols. And similarly, for relational operators, equal, not equal, and so on, instead of saying using the double equal sign, you can use the word eq, and e, less than, greater than, less than or equal to, greater than, equal to, and so on. So these are just alternative ways to write some existing Java operators. Now, the only new operator is this empty operator, which does not exist in Java. Remember that in Java, when we try to check if a string is null or empty, we have to write a fairly long statement, and we have to say if string is null, or if string.length is 0, then something. And because checking for an empty or null string is so common in web programming, for example, it's quite often that we have to check whether a parameter is empty. Expression language actually introduced a new operator called empty to just check whether something is null or it's an empty string. And this is a pretty handy operator, which you'll probably use quite often. And then there are some other operators which have slightly different meanings in expression language. As we saw in our previous example, the bracket operator in Java is used for array index, and in expression language it's also used for array index, except that it will also accept string values in addition to integers. And similarly, the dot operator in Java is used to referring class fields or methods, and in expression language they are used to refer to properties. they have basically similar meanings as in Java, but behave in a slightly different way. Although most expression language operators look more or less the same as their Java counterparts, sometimes they do behave a little differently. So you need to be careful when you first use them. Once you use them a little bit, you kind of get the subtle differences. But when you first use them, don't make assumptions. It's better that you try a few examples like what we have here, understand what the results are and why it produced those results, and then later on it becomes something natural so that you don't have to worry too much about it. With that said, let's look at a few of these examples. So for example, let's say we look at this arithmetic operators, plus and division. So if we do something like this, let's say we write expression language expression that says 2 plus 4 over 2. Now we would expect the result of 4, right? That's 2 plus 4 over 2 is another 2, so it should give us the result of 4. And it shows 4.0, which is close enough. And then how about 2 plus 3 over 2? In Java, 2 plus 3 over 2 will actually give us 3. The reason being that both 3 and 2 are integers, so 3 over 2 will produce another integer. So it will get 1.5, but 1.5 will be truncated into 1. So in Java, if you try this expression, you'll get 2 plus 1, which is 3. In expression language, however, it gives us 3.5. And from this example, you can see that expression language doesn't do truncation like in Java. If you have 3 over 2, you get 1.5, you don't get 1. Or another way to look at this is it treats basically all numbers as floating point numbers instead of distinguishing between floating point numbers and the integers. This is also the reason why we get 4.0 in our previous example instead of just 4. So once you understand that, it becomes quite easy to understand. Now how about string 2 plus 3 over 2? Now in Java, you probably would expect this produce a result of 2 1.5, where 1.5 gets converted into a string and concatenated to the string 2. So we'll have a string of 2 1.5. In expression language though, it's still 3.5. So what we are having here is in fact another example of the application server automatically converting a string into an integer or into a number here. And once again, this is because in web programming, all the data originally is text. The data exchanged between the client and server. Think about HTTP request and response, and all the data in request and response are text. So oftentimes you have to convert some text into numbers, and the expression language tries to do that for you. So when it sees a string that looks like a number in a context that seems to require a number, then it will automatically convert it into a number. And this is why this string 2 plus 3 over 2 is still producing 3.5. And this one should give us the same value. It's simply using another way of saying division. So this div is equivalent to the division operator. And how about this one? So let's say we have a plus 3 over 2. Again, in Java, you would expect the result to be a 1.5. Again, 1.5 gets concatenated to a string a, so it produces another string a 1.5. In expression language, however, we are going to get an error. And the error says number format expression for input string a. So what's happening here is that it tries to convert a into a number because it look at this expression and thinks that we are trying to do a numeric addition here, and a of course is not a number. Again, this is quite different from the Java behavior, and you'll just need to get used to this. It looks somewhat the decision looks somewhat arbitrary when it tries to convert something and when not. If you read the JSP specification, it actually lists all the situations where automatic conversion should happen. But then again, nobody would remember all those different situations. So just pay a little bit attention and be a little bit careful, and you should be fine. So this one is actually an error. Now equals to a string. Of course, this should be false. And let's check this one. So is now equals to a string now, or in other words, is the application server going to convert this string into a null value? Well, the answer is false. It's still treated as a string, and the null, of course, is not equals to a string, which is why the result here is false. And let's try the empty operator. So if we have a empty operator and we use an empty operator to check for an empty string. So notice that this empty operator is a so-called unary operator, meaning that this operator only takes one operand instead of a binary operator like the plus operator. So this one basically says check if this value is empty, and the result is true. So if the value is an empty string, it will return true. And how about now? Well, it will also return true. So as you can see, this operator, empty operator, can be used to check both if something is empty or something is null, and that's quite convenient. And if something is not null, for example, if something is actually a string, it will produce the result false. And let's try comparison operator. As in Java, we can certainly compare numbers, but how about comparing strings? For example, is the string ABC less than the string B? Well, let's find out. Is ABC less than B? The answer is yes. Why is yes? Well, as you can imagine, when we compare two strings, it's comparing them in alphabetic order. So alphabetically, A goes before B, so this string ABC is considered less than the string B. And if we try something like CS320 greater than CS203, and the answer would be yes again, because alphabetically 3 comes after 2. So CS320 is greater than CS203. So the moral of the story is that in expression language, the comparison operators can be used to compare strings in addition to numbers. There are a lot more this type of examples you can do, and the bottom line is that be aware that expression language operators behave slightly different from their Java counterparts. So when in doubt, do a simple example like this to check it first. Okay, now that we know about the literals and the operators, let's talk about variables. First of all, know that you cannot define new variables in expression language, because after all, it is expression language, and you need statements to define new variables. However, we can use EL to access existing variables, including bins, implicit objects, and scope variables. Bins are the objects defined using the JSP useBin tag, like BA and BB. And the scope variables are the objects saved in the application or session or request or page scope using the setAttribute method in the servlet code. And we also know who they are. But what about the so-called implicit objects? Well, implicit objects are a number of objects that are already defined in the expression language, like page context, param, cookie, and so on. There are also request, response, session, and servlet context, and these are the properties of the page context object. If you remember the predefined variables for scripting elements, and that's this ones. In scripting elements, remember that there are a number of variables that are predefined, so we can simply use them without declaring them ourselves. And these are called predefined variables in scripting elements. Now, in expression language, it's the same deal. There are a number of objects that are already defined for us, and we can use them directly in expression language without having to declare them first. And let's use an example to see how to use these implicit objects. And what's wrong with my JSP here? Well, let's ignore it. Sometimes Eclipse just have some false alarms. Okay, so let's create our new JSP, and I'm going to call it request info, because I want to use this JSP to display some information about the requests. Okay, so let's say what we want to know about the request, and let's say the first thing I want to know is the request method. So how do we get the request method in expression language? Well, notice that among these implicit objects, we have a request object. And to get the request object, we know that it's a property of the page context object. So that means we will say page context dot get request. So this gives us the whole request, but we only want to know the request method. So how can we use this request object? Well, remember that a request is of the type HTTP servlet request. And that's always true, whether it's in expression language or in scripting elements or servlet. So if we want to find out how to use a request, we look at the documentation. So we go to our documentation, and where is the documentation? Here. And we look up the HTTP servlet request, and that is here. And this is the type of this request object. And this API documentation gives us all we need to know about how to use it. In particular, notice all these getters in this class or in this interface. Remember, properties are defined by getters. So all these getters can be accessed as properties inside the expression language. For example, if we want to know what's the method of this request, well, here's a getter get method. So how about we simply say dot method, and just like that. So if we say request info, notice that now it says the request method is get. So we can do quite a bit more with this, because there are, as you can see, lots of getters in this API. And for example, if we want to know who's the remote user, how about remote user and remote client address. So remote user, we can see where is the remote user. Yes. So it says get remote user, and that means the property is called remote user with lowercase r. And how about client address? Client address, we look a little bit further down, we see that there's a inherited method called get remote address, and so that this getter, notice get remote address, gives us the property remote addr, and it's as simple as that. And it cannot get the remote user, but it does get the remote address or the client address, which is the local host. So the first important thing about this example is to understand that these implicit objects are still Java objects. So if you want to find out how to use the object, all you need to do is to read the API documentation and then look for the getters. And from the getters, you have the properties, and from properties, you can simply access them in expression language like this. The second thing about this example is to show how to access a couple of important objects, in particular the request parameters. Request parameters are something that you are going to use a lot, and the way to access request parameter in expression language is actually quite simple. So we can say param a, and the request parameter is simply param.a. Request parameter a and b. So this is param a and this is param b. So if we refresh, notice that there's nothing here because we didn't specify any request parameter. So how about we say a is 10? Notice that it shows 10 here, and b is hello. It shows hello here. So in other words, to access request parameter, you simply say param dot the parameter name, and that's it. And another way to access request parameters is to say param a as if it's an array, and you can say param b as if it's an array. So these two syntax are the same, and you can either say dot parameter name or bracket parameter name as a string, and it works the same. You can see 10 here, 10 here, hello here, hello here. Now, for people who only know Java, this syntax may look kind of weird because Java only allows integer indexes for arrays. But for people who are familiar with some other languages, especially scripting languages, this is actually a pretty natural syntax. In most scripting languages, the so-called associative array is allowed. Associative array basically meaning that the array index can be anything. It doesn't have to be integers. It can be strings or other objects. And in terms of Java, you can think of associative array as maps in Java, where the array index is actually the map key. Anyway, we're not going to get into the structure of programming languages. To keep it simple, just remember that you can access request parameters either in this form or in this form. And one last thing I want to show is how to access cookie. Remember that in servlet, if we want to get a cookie with a certain name, like JSessionID, we have to say request get cookies, which will return an array of cookies, and then we have to go through each cookie, check the name to find the cookie we are looking for. With expression language, the code becomes a lot simple. So we simply say cookie and then give the cookie name like JSessionID, and this would return the cookie like this. But notice that it returns the whole cookie object, which looks like this because this is the default toString method of an object. It returns the object type and then the object code. What if, for example, we want the cookie name or cookie value? Well, we do the same thing as before. We go to the documentation, we look for the cookie object, and in the cookie object, notice that we have comment, domain, max name, name, pass, value, all those getters. And if we want a value, well, how about dot value? And that's the value of that cookie. Again, look up the API documentation, find the getters, and use the property based on the getter, and that's that. So once again, two things about this example: how to use implicit objects and how to get access request parameters. So this is the end of the story about expression language. As you can see, it's a very simple language, very easy to learn and very nice to use. The problem is that it only has expressions, and sometimes it feels too limited. For example, we can display individual values in an array, like in this example. But we cannot display all the values in the array because it would require a loop statement. To go from expression to statement, we need something more, and that takes us to the next topic, JSTL.